What is latency? Latency refers to the delay or time it takes for a data packet to travel from the source to the destination. In the context of computer networks, latency is often measured in milliseconds and is a critical factor that affects the performance of network based applications such as websites, streaming services, and online games. Key concepts related to latency: 1. Propagation delay. Definition: the time it takes for a signal to travel from one point to another in a medium, such as a fiber optic cable or wireless channel. Factors affecting: distance between the 2 points, the speed of light in the medium. Example: a signal traveling through a fiber optic cable from New York to London experiences a propagation delay because it takes time for the light to move across the Atlantic Ocean. 2. Transmission delay. Definition: the time it takes to push all the packet's bits onto the transmission medium. It is calculated based on the packet size and the bandwidth of the communication link. Formula: transmission delay equals packet size bandwidth. Example: if you are sending a 1000-bit packet over a 1000 megabits link, the transmission delay would be 1 microsecond, moches. 3. Processing delay. Definition: the time it takes for a router or switch to process a packet header and decide where to forward it. Factors affecting: router performance, packet complexity, and routing table size. Example: a router needs to inspect the IP address in a packet to determine the best path. The time spent in this decision-making process is the processing delay. 4. Queuing delay. Definition: the time a packet spends waiting in a queue before it can be transmitted. This delay occurs when network devices like routers and switches have packets that need to be sent out but are temporarily held back due to congestion. Factors affecting network traffic load, queue management algorithms. Example: during peak hours, if many users are trying to access a website simultaneously, the packets experience a queuing delay at the server or routers due to congestion. A 5. Round trip time, RTT. Definition: the total time it takes for a signal to go from the source to the destination and back to the source. Importance: RTT is crucial in applications where acknowledgement of data receipt is necessary, such as TCP connections. Example: when you ping a website, the time it takes for the ping to reach the server and for the server to send a reply back is the RTT. SIG jitter. Definition: the variation in latency over time, often caused by network congestion, route changes, or other network conditions. Importance: high jitter can negatively affect real-time communications like video calls or online gaming. Example: in a video call, if the audio and video signals arrive with varying delays, it leads to a choppy or out-of-sync conversation. Types of latency. 1. Network latency. Description: refers to the delay in data communication over a network. This is a combination of propagation, transmission, processing, and queuing delays. Example: when you load a web page, the time it takes for the request to reach the server and for the server to send the web page data back to your browser is network latency. 2. Application latency. Description: the delay introduced by the software application in processing data. It includes the time taken by the application to process user input, interact with other services, and render the output. Example: in a video editing software, application latency might be observed as the time taken to render a video after editing. 3. Storage latency. Description: the delay in accessing data from storage devices like hard drives or SSDs. Factors affecting: type of storage media, read-write speeds, and data fragmentation. Example: when you open a large file stored on a traditional hard drive, it might take a few seconds to load due to storage latency, which would be significantly reduced with an SSD. Before, more server latency. Description: the time it takes for a server to respond to a client request. This includes the time taken to process the request, retrieve necessary data, and send back the response. Example: when you search for a product on an e-commerce website, the server latency is the time taken by the server to process the search query and display the results. Factors affecting latency. 1. Distance. The greater the distance between the source and destination, the higher the latency due to increased propagation delay. 2. Bandwidth. Higher bandwidth reduces transmission delay, allowing data to be sent faster. 3. Network congestion. High traffic can cause queuing delays, leading to increased latency. 4. Hardware. The performance of routers, switches, and servers can affect processing delays. 5. Protocols. The efficiency of communication protocols like TCP/IP can influence latency. 6. Environmental factors. In wireless networks, interference and signal quality can also increase latency. Real-life use cases and examples. 1. Online gaming scenario. In multiplayer online games, low latency is crucial for real-time interactions. High latency, also known as lag, can lead to delays between a player's action and its effect in the game, causing a poor gaming experience. Example. In a first-person shooter game, if you shoot at an opponent but there is a high latency, your shot might register late, giving the opponent an advantage. 2. Video conferencing. Scenario. For a smooth video call, low latency is essential to ensure that the conversation flows naturally without delays. Example. During a Zoom meeting, if there is high latency, you might notice delays between when someone speaks and when you hear their voice, leading to interruptions and difficulties in communication. 3. Web browsing. Scenario. Users expect websites to load quickly. High latency can result in slow loading times, which can frustrate users and lead to them leaving the site. Example. If a user is trying to access a website hosted on a server far away, the increased network latency might cause the page to take longer to load, affecting user experience. 4. Cloud computing. Scenario. In cloud services, latency affects the performance of applications that rely on cloud resources. This is especially important in real-time applications like online gaming, financial trading platforms, and collaborative tools. Example. In a cloud-based virtual desktop environment, high latency can result in slow response times when opening files, running applications, or interacting with the desktop interface. 5. Autonomous vehicles. Scenario. Autonomous vehicles rely on real-time data from sensors and other vehicles to make decisions. Low latency is critical to ensure the vehicle can react promptly to changing conditions. Example. If an autonomous car needs to brake suddenly to avoid a collision, high latency in the communication between the car's sensors and its decision-making system could lead to delayed braking, potentially causing an accident. Measuring and reducing latency. 1. Ping and traceroute. Ping, a tool used to measure the RTT between two devices. It sends ICMP echo requests to the target device and measures the time it takes to receive a reply. Traceroute, a tool used to trace the path that packets take to reach their destination, providing information on each hop and its associated latency. 2. CDNs, content delivery networks. Function. CDNs reduce latency by caching content closer to users, thereby reducing the distance data needs to travel. Example, websites like Netflix use CDNs to deliver content to users more quickly, reducing buffering times and improving the streaming experience. 3. Load balancers. Function. Load balancers distribute network traffic across multiple servers, reducing the processing load on any single server and minimizing latency. Example. During a major online sale, an e-commerce site might use a load balancer to ensure that no single server becomes overwhelmed, thereby maintaining low latency for users. 4. Optimizing network infrastructure. Upgrading hardware. Using faster routers, switches, and servers can reduce processing delays. Network topology. Optimizing the layout of the network to reduce the number of hops between source and destination can lower latency. Conclusion. Latency is a critical factor in the performance of networks, applications, and various real-time systems. Understanding the different types of latency, the factors that affect it, and how to measure and reduce it is essential for optimizing the user experience in digital environments. By recognizing the impact of latency in real-life scenarios, businesses and engineers can design more efficient systems that meet the needs of users in a fast-paced digital world.